Explore network protocols. The addressing table R1 with two interfaces. This is R1. R3, two interfaces. R3. Firewall with three interfaces. This is the firewall. The DevNet associate server, the private IP address and public IP address. This example server on internet is this PCI and PCB. PCI and PCB. Many services run on networks behind the scene to make things happen reliably and efficiently. As a developer, you should understand what services are available and how they can help you. You should also understand the basics of how the most useful and popular services are configured. The two web servers are referred to as DevNet Associate Server and Example Server. In the topology, they are named with the URL www.devnetassociate.pki. This and www.example.com. This another. Configure DNS. All of the hosts on a network are assigned an IP address. The IP address can be an IPv4 address, an IPv6 address, or both. This includes all the hosts on the internet too. But you do not use their IP address to communicate with them. You use common names such as cisco.com. The main name system, DNS, is the service that automatically translates the common, easy to remember names into IP addresses so that the communication can take place between devices. In this packet tracer activity, the devices are using IPv4 addresses. Configure a local DNS server. Click the corporate server, services DNS. This is the corporate server. Click here, services DNS. On, okay, turn on. Now that DNS has been enabled, you would like to translate their name to an IP address. In the name box, type www.example.com. Okay, for this server, www.example.com. Go to corporate. Corporate will be the DNS server and www.example.com, and use this IP address 64.100.0.10 and add. Okay, is a record and add. Ready. And now you have the record for this server, www.example.com, with this IP address 64.100.0.10. You will now see the entry that shows the hostname and IPv4 address of the example server. Is this. Okay. This is where DNS will look for the hostname and return the IPv4 address of that host to any device that requests it. Configure and test the use of a local DNS server. Click on PCA, config, DNS server box. Okay, go to PCA. You can go to config and set the DNS server here, or use the following: go to desktop, IP configuration, set the DNS server here. Type the IP for address of the corporate DNS server. Okay, review the IP address of the corporate DNS server. Go to desktop IP, and is this 192.168.1.3. 192.168.1.3. So on PCA, set that IP address 192.168.1.3. Okay. You can review on config. Is also configured. Okay, don't worry. Now, when PCA uses common host names, it will send out a DNS request for the IP4 address of the host with that name. On PCA, here, desktop command prompt. Okay, command prompt. Ping www.example.com. www.example.com. Okay, the ping may not work the first time as the network converges. So repeat ping www.example.com. Success. Now you can see the translation. This domain is assigned to this IP address and is this server. So from PCA you can use names. Configure and test the use of a remote DNS server. PCB does not have a local DNS server, therefore it will use the example server as its DNS server. Go to PCB. Go to PCB, desktop IP configuration. In the DNS server box, type the IPv4 address 64.100.0.10. And now for PCB, the DNS server will be this server on internet, the example.com. Okay, PCB will use this DNS server on internet. So on DNS server, set the IP address of example.com 64.100.0.10. Go to desktop command prompt and ping www.example.com. Okay, and review the example.com server. Go to services, DNS. Now it has this record, so you will be able to ping www.example.com. Go to PCB. This is the DNS server on internet. Close this, command prompt, and ping www.example.com. Enter. May take a while. Okay, success. Now the name is translated to the IP address. Ping www.DevNet associate netacat.pka. Okay, review the DNS server. It has the record. go to PCB, ping www dev associate net acat.pka. Enter. Okay, this name is translated to this IP address. Try again. Okay, success, repeat. Very good. Close the command prompt and click web browser. Okay, on PCB, close command prompt, web browser, www.example.com. Go. Success. You should now see the example.com web page and www.devnet associate-netacat.pka, www.devnet associate-netacat.pka. Go. Success. Okay, now configure the DHCP. Manual configuration of IPv4 addresses is fine for very small networks. But on larger networks, it is necessary to automatically provide IPv4 addressing to devices when they connect to the network. Dynamic Host Configuration Protocol, DHCP, provides this service. It is also convenient when devices are moved because if they move to a different subnet, they will get a new address and be able to communicate with other hosts. Another great feature about DHCP is that it automatically sets not only the IPv4 address for a host, but also the subnet mask, default gateway, and DNS server address. This makes it very easy for multiple pieces of information to be configured on hosts automatically. Click the corporate server, services, DHCP. Corporate server again, services, DHCP. Turn on the service, okay, DHCP on. You will now define a pool of IPv4 addresses that you wish to assign to hosts. You will use the IPv4 addresses in the 192.168.1.0 subnet. Okay, for this subnet, 192.168.1.0.24, you cannot use the address of 192.168.1.1 because it is already in use by the firewall interface. Okay, the firewall uses the number 1. You also cannot use the corporate server address 192.168.1.3. Okay, remember the corporate address is 192.168.1.3. Okay, go back to the DHCP. And it is a good practice to leave some addresses free for statically assigned to servers or other devices where you want their address to remain the same. The pool name is currently server pool. Okay, this is the pool name. Do not change it. For the default gateway, enter the IPv4 address of inside interface of the firewall 192.168.1.1. Okay, you know the default gateway for this network is the firewall, this interface on the firewall. Okay, so the default gateway is 192.168.1.1. This will provide each DHCP host a route to other networks. This is the function of the default gateway. Okay, and set the default gateway 192.168.1.1 to reach other networks and internet. For the DNS server, enter the IPv4 address of corporate server 192.168.1.3. Remember, corporate server is a local DNS server, so use this. The DNS server will be 192.168.1.3, the corporate server. This will provide each DHCP host and others to use to send DNS messages. For start IP address, use 192.168.1.10. Okay, the pool will start with 10. This provides for a few statically assigned devices on the network in the future. Subnet mask 255.255.255.0, 255.255.255.0. For maximum number of users, enter 245. The remaining amount after setting 10 aside. Okay, 245. Okay, if the start address is 10 and you have 245 available IP addresses, you will have the range from 10 to 254. Okay, save. Okay, save. And now this all information is placed here. The server pool, the default gateway, DNS server, start, subnet mask, maximum number of users. Test the DHCP, go to PCA, close the command prompt, go to IP configuration and change static to DHCP. And you will get the first address is 10, subnet mask, default gateway, and DNS server. You should be supplied with an IPv4 address. You should also see the subnet mask, default gateway, and DNS server. Very nice. Configure NTP. The clock on a router or a switch is important for managing, securing, and troubleshooting networks. Even on small networks, it is important to synchronize the time across the devices. Trying to do this manually is almost impossible, specifically for large networks. Network Time Protocol (NTP) can be used to synchronize the time on each device by receiving it from an NTP server, ensuring that the times are all the same. Turn the NTP service on. Go to Corporate Server, Services NTP. Corporate Server will also NTP server. Go to NTP and turn on. Investigate NTP on S2. S2 has already been configured to use the corporate server as its NTP server. Click on S2 command line interface. Okay. So switch number 2 is the client, the NTP client, and corporate server is the NTP server. Go to S2 and review. Command line interface. Enter. Enable. The password is Cisco. Now you are on privileged exec mode. Display the current time and date using show clock detail. Now you can see the time zone, the end date. Obviously, this is the time source is hardware calendar, so it's 1993. Obviously, is incorrect. Notice that the time is set by hardware and is not accurate. You can manually configure the time with the clock command. However, a better practice is to use an NTP server. Enter the global configuration mode with the configure terminal command. Configure terminal. Enter. Sorry, configure. Enter. Okay, now you are on global configuration mode, as you can see, and configure S2 to use the corporate server as its NTP server. Exit global configuration mode and verify S2. Okay, and set the NTP server. The NTP server is the IP address of the corporate server. NTP server 192.168.1.3. Enter. Exit global configuration mode and verify S2 is now using the NTP. Your time and date should now be accurate. Exit. Exit from global configuration mode to privilege exec mode. Show clock detail. Okay, it's 1993. It may take some time before the source is updated to NTP. Okay, so wait a moment. Show clock detail. Show clock detail. May take a while. Show clock detail. Okay, ready. And this is the accurate date and time. And the source is not the hardware. The source is network time protocol (NTP). Okay, remember this is the date and time of the server. The date and time of the server. Look at the year. Use SSH to securely access a switch. Secure Shell SSH is a protocol that is used to encrypt communication between a client and a host. SSH is the preferable connection type because it is secure in comparison to Telnet. SSH has already been configured on S2. Okay, S2 has already been configured with SSH. Go to PCA. Desktop command prompt. Okay, go to PCA. Go to command prompt. Attempt to establish an insecure Telnet session to S2. Okay, remember Telnet is an insecure procedure, but use anyway. Telnet 192.168.1.4. Okay, 1.4 is the IP address of the switch. 1.4 is the IP address of the switch. Enter. Close it. Okay. Switch 2 denies your request because it is configured for SSH access only. Enter the command SSH and press enter to see how to use the command. Note that the option is a lowercase else and not a number one. Okay, use SSH, enter. Okay, use SSH -L, L lowercase, username, and the target is an IP address or name. Okay, so use the following: SSH-L, the username is administrator, and the IP address of the switch 192.168.1.4. Okay, SSH-L, username and destination, IP address of the switch, enter. And password is Cisco, enter. Now you are on the command line interface of switch 2 with using a remote connection using SSH secure shell. You are now accessing the command line for switch 2 over a secure connection. Okay, use enable. Password is Cisco. Okay, now you are on privilege exec mode. You can use, for example, SSH or show SSH sessions. Okay, only show SSH. Now you can see a session started by administrator. Okay, administrator is the username and session started. Okay, and exit to close the session. Exit. Very good. Investigate Snmp MIB object IDs. Simple Network Management Protocol (SNMP) can be used to get and set variables related to the status and configuration of network hosts like routers and switches, as well as network client computers. The SNMP manager can poll SNMP agents for data, or data can be automatically sent to the SNMP manager by configuring traps on the SNMP agents. You will retrieve the management information base (MIB) object ID codes to learn the details of the messages using the MIB browser. Cisco devices use community strings to authenticate access to the management information base (MIB). This is where all of the information about the device is stored. A community string is simply a plain text password. Community strings can be either read-only or read-write. These community strings have been created for you on R3 so that you can investigate the MIB. Okay, R3 is configured. Although SNMP can be programmatically accessed to manage the network, more sophisticated tools are now available, as you will see in the rest of this course. However, SNMP has a large install base in networks today and will continue to be a valuable management tool for the future. Follow these steps to investigate the simulation of SNMP in Packet Tracer. Click PCB, click MIB browser. Okay, go to PCB, go to MIB browser, enter the address of R3. Okay, R3 the IP address of this interface. So it's 172.16.3.1. 172.16.3.1. Click Advanced. Click Advanced. Enter a read in the field of for read community. Okay, read is a password. Write in the field of write community. Another password. Password to read. Password to write. Version 3 for Snmp. Okay. Ready. Okay. Expand the tree. MIB tree. Expand this. Router std MIBs. This. Expand this. Router std MIBs. And continue expanding. Expand, 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 expand until you reach MGMT. Okay, this is MGMT. Expand MGMT. Continue expanding to reach that system. Okay, expand. Okay, this is system. Expand system. Click sysname. Okay, this sysname. Go. Okay, click here. Go. Now you can see this. You will now see the value of the object is R3. Okay, the value is R3. You can look at other objects in the MIB, such as the interfaces on the router. This is the host name. Sysname is the host name. So that's why the value is R3. You can see, for example, the interfaces, interface table, interface entry, status. Okay, you can go to interfaces, table, entry, status, operation status, then go. And now you can see 3 interfaces. But only 2 are used. 2 interfaces are used. So that's why 2 are up. Because you are using only 2 interfaces. The third interface is not in use. Okay? You will see that 2 of 3 interfaces are up. Now, configure HTTPS. When you connect to a server using HTTP, you connect and assume that is the correct server. The data transferred between you and the server is sent in plain text. So if anyone captured the data, they could read and manipulate it. Normally, this isn't a problem if you are simply browsing the internet. But if you are creating an account, accessing an account, or providing any personal information, it can be captured and used by someone else. Secure HTTP or HTTPS adds a layer of security by encrypting the connection between you and the server. A site must possess a security certificate from a trusted source to verify that the site is legitimate. Your browser checks that the certificate is valid and from a trusted source before connecting you to the site. Okay. Open your web page from a PC on PCB, desktop web browser. Okay, this is PCB, and close this web browser. Enter the DevNet associate server www.dev-associate um, dev-associate-net.pka. Go. You verified access earlier. However, after you click go, notice the protocol is HTTP. Okay, the protocol is only using HTTP. Examine the firewall. Click Firewall CLI, enter. Go to the firewall. Remember, you are accessing to this server. From PCB, you are accessing to this server, the DevNet associate server. So you need to review the firewall. Okay, this is the firewall command line interface. Enable. No password, enter again. You are on privileged access mode. Show run. Show run to view the configuration of the firewall, enter. Space. Okay, use a space bar to scroll through the firewall configuration. Space. Notice the following two configurations in the outside DMC access list. Okay, this is the outside DMC access list. Okay, this permits the ICMP protocol, permits ping, but the line with www allows port 80, which is the unsecured HTTP traffic. This is for HTTP because this is the port 80 for HTTP only. This is the access list. The name of the access list is outside DMC. It's an extended access list. Permit or allows the TCP protocol from any source, and the destination is the server, the DevNet associate server. Look at the private IPv4 address here, 192.168.2.3. Okay, from any source to the destination server 192.168.2.3, and use the port 80 or HTTP. And the line with port 443 allows port 443, which is the port used by secured HTTP or HTTPS. And this permits to access the HTTPS. Okay. Remove the access list statement that allows unsecured HTTP traffic on port 80. Okay, go to global configuration mode with configure terminal command. Configure terminal. Once you are on global configuration mode, as you can see, use the no command, no space, and copy this and copy this entry, the entry with the www, and paste. Okay, so you will remove this line. You will remove this line. Enter. exit and review, show running config, enter, space. You will only permit ICMP, ping, and you will only permit HTTPS. Configure HTTPS. Go to the DevNet associate server. Okay, go to this server. Services HTTP. Services HTTP. Notice HTTP is on, but HTTPS is off. Turn HTTP off and turn HTTPS on. HTTP off, HTTPS on. Even though the firewall will no longer allow HTTP access, it is best practice to also configure the server to only allow HTTPS. Okay, verify. Go to PCB. Verify PCB can no longer access www DevNet associate netacad.pka using HTTP. Okay, HTTP :// DevNet associate netacad.pka. Go and wait a moment. Okay, request timeout. After a few seconds, you should get a request timeout message. Change HTTP to HTTPS. Only add the HTTPS : / and so on. Go. Very good. Configure email. Email clients use Simple Mail Transfer Protocol (SMTP) port 25 to send email to a server. SMTP is also used to send email between servers. Email client uses Post Office Protocol 3 POP3 port 110 to retrieve mail from the server. Okay, remember SMTP port 25 to send email to a server, and POP3 port 110 to retrieve mail from the server. Configure email server. Example server. Okay. This will be the email server, the example server on internet. So click here. Services email. Services email. Turn on SMTP and POP3. SMTP on, POP3 on. Enter www.example.com is the domain name. www.example.com. Okay, don't forget www. And click on set. Okay. Create users. Student 1 case sensitive class for the password. Student 1 password class. Okay, case sensitive student and plus. Okay. Click here. Now, user added. Repeat the step for student 2. Student 2 password class. Add with plus. Okay, now you have 2 users. Now, this is the server on internet. And configure the client's PCA desktop email. Okay, client PCA will be the client. PCA. Close this. And desktop, search for email, this email, and your name, your email address, incoming mail server, outgoing mail server, obviously the IP address of the server. We go to PCA, student 1, email address the same, with at www.example.com. The IP address of the server, username, student1, Control C, Control V. Remember, password is class that was configured on the server and saved. Repeat this configuration for PCB, but use student number 2. Okay, PCB will be another client. Close the browser, open email, and should be student 2. And www.example.com. Example.com. The IP address 64.100.0.10. Password, remember, class. Password is class. Student 2, student 2, student 2. Save. Send and receive email. On PCB, open email and click compose. Okay, go to PCB. This is email and compose. Send an email to student1, student1, www.example.com. Subject only in email test, and how are you? How are you? And send success. Down here, look at this, send success. And verify on PCA. Okay, you send you send an email from PCB to go to PCA to verify, and click on receive. Okay, receive, and this is an email from student 2, the subject and the content. Reply. Okay, reply, and click here on reply. You can respond with fine. Send success down here, and verify on PCB. Go to PCB, receive. Now you received the message. Configure FTP. File Transfer Protocol (FTP) is a commonly used application to transfer files between clients and servers on the network. The server is configured to run the service where clients connect, log in, and transfer files. FTP uses port 21 as the server command port to create the connection. FTP then uses port 20 for data transfer. Configure the server, and corporate server. Okay, corporate server will also be the FTP server. Services FTP. Go to corporate, services FTP. Turn on the service username student password class. Okay, add there is an existing user Cisco username and password Cisco, but add another student case sensitive and password class and add. Now you have two users. Check all of the boxes below these fields to see the user permission to allow write, read, delete, rename, and list. Okay, remember, select this and be sure write is selected, read selected, delete selected, rename selected, and list selected. Okay, all privileges and use FTP service. Click on PCA, go to PCA. So corporate server will be the FTP server and PCA will be the FTP client. Go to PCA. Go to PCA, close the email, command prompt, dir, and to list the local files, dir. You have this file, sample file, the txt file. This is your local directory, and the local directory of PCA. Okay, dir to see the files on the PC, and FTP to the corporate server, IP4 address. Okay, use FTP connection to the IP address of the corporate server. And remember, the IP address is 192.168.1.3. Go to PCA, FTP 192.168.1.3. Enter. And add the username. Remember, the username created with student, case sensitive, and password is class. Log it in. Very nice. And this is the prompt of FTP. Enter this character and press enter to see the commands available. Okay. Enter. You can use cd, delete, dir, get, help, zip, quit, and others. Dir to list the files available on the server. Dir. Okay, a lot of files available on the server. These files are placed on the server and put sample file.txt to send the file to the server. Remember, you have a local file, a txt file on your PC. You will send this file to the server. And look at this, a lot of files. The server doesn't have a txt file, so send the file to the server with put and use the same name of the local file. Use this. Enter. Transfer complete. Verify with dir. Use dir again on the server. Now you can see the file at the end. This is the size of the file. And now enter get asa a42-ka.bin to retrieve the file from the server. Okay, you can download this file from the server to the PC. Okay, so use get space, copy this name, enter. File transfer in progress. This can take 30 seconds or more to complete. Okay, wait a moment. About 30 seconds. May take a while. Okay, transfer complete. Copy it in 30 seconds. Very good. And delete the txt file to remove the file from the server. Okay, delete this file, the txt file. Delete and copy the name of the file. Paste, enter. Okay, delete it. Use dir to verify. And no txt file on the server. Quit to exit the FTP client. Quit. Now you are on your PC and display the contents of the directory on the PC, dir, and now you have the downloaded file from the server. Thank you very much, 100%.